The cloud also allows you to have an expert system close to yourself, but because it is connected to the sources out there, suddenly it is very powerful. And I cannot wait. In fact, it's fascinating to see how we can use that and apply it to the wealth of our customers and mankind in the end.
Welcome to Innovation Talks. Join us weekly as we discuss with distinguished industry guests how to refine and improve corporate innovation and new product development as businesses aim for long-term success. Hosted by Paul Heller, Sopheon CTO.
If you're looking for additional information around new product development or corporate innovation, sign up for Sopheon's newsletter where we share news and industry best practices monthly. The fastest way to do this is to go to Sopheon.com. That's Sopheon.com, and click the sign up and stay informed box. Hello, everybody. My guest today is Dr. Huub Rutten. Huub has a degree in Applied Linguistics, and he began his career as a professor and developed teaching curricula focused on skill development, decision-making systems, and AI. Fun fact, during that time, he actually published textbooks in various languages, which are still being used today. Then he moved into consulting and focused on business process integration, working with businesses and also public entities such as the European Commission. In 1993, he co-founded Sopheon and was instrumental in its development of linguistics and knowledge management technologies, eventually leading Sopheon into solutions for innovation. He continues to lead Sopheon research to this day. Huub, it's a real pleasure to have you on our podcast.
Pleasure to be here, Paul. Thank you for having me.
And how are you today?
I'm good, So, as you know, I live in the south of the Netherlands, and it looks like the spring has arrived. It's blue sky, sunny weather. So everything is beautiful. Not too long ago, we had a heavy freezing, and now we are 1 week later, and the difference is a lot. So everything is fine.
Ah, there you go. Good. That's a great way to start a day. Well, Huub, you've had a very interesting career thus far, and I know that one area you've worked on is the application of artificial intelligence and machine learning in innovation. Could you share some of your observations and thoughts about that?
Yeah, okay. So, Paul, look, if you use the word AI, artificial intelligence, and then machine learning, the first thing that you see in the market is that there is a lot of confusion around it. There are many, many people that use the word also in marketing without having a clue of what it really is. So machine learning and AI is mixed. AI is a broad thing. So the first time I learned about it was, in fact, when I used to work in psycholinguistics. The psycholinguistics, the language is the theory of language and thinking. And in psycholinguistics, they used computers to imitate, if you wish, so the thinking of people. So they started to work on thinking computers to analyze the thinking of people. And next to that, you have machine-aided translation. So as you know, in Europe, we are in a multilingual area, and the world is multilingual. And there was the idea of, if you have machine-aided translation, that the intelligence of AI could be applied to that. And now I talk about almost 40 years ago, let's say 35 years ago, 40 years ago. And today, you see that in the speech technology, some of AI stuff is in there. There's also machine learning, of course, in there, which is not the same. I will talk about that later. You see that the AI was I think in the beginning of 2000, 2010, AI was gone. Nobody was talking about it anymore. It seemed to be that it was a hype. But now AI is completely back. And AI is back because there is a kind of a evolution of system to be autonomous. It started, in fact, with banking. To get a mortgage, the banks install simply an expert system, which is also AI, an expert system, and to evaluate the request for a mortgage. And there are hundreds, if not thousands, of expert systems around in the world based on the same principles. That you have knowledge of domain on the one hand, and on the other hand, you have decision rules to work with that domain knowledge, and then you take a decision based on that. That is really, expert systems are really born from the artificial intelligence movement in the 80s and the 90s and after that. Then if you have that is almost like the beginning of AI, and that's very useful. The artificial intelligence is intelligence that is artificial, so it's not intelligence. It is calculation. It is in that sense, stupid, Paul. Artificial means artificial. That is really a good word. And machine learning is something else. I will talk about it.
Good. Okay.
So once you have these applications of artificial intelligence to expert systems, you can use the techniques of expert systems to many things. And I always thought for our business that for the decision making of which new products to choose, how to prioritize things, how to measure things against, and let's say how to interpret things against certain parameters with certain values, that principle of an expert system to evaluate a mortgage, yes or no, you can apply that also to portfolio management. You can apply that to product management. You can apply that to any situation where you have data, where you have, on the one hand, you have knowledge of the world, of the other thing, and in the middle, you have your rules, standard rules that you apply as a reasoning mechanism. It's called reasoning. So, and reasoning is not more or less than, in the end, rules, algorithms, whatever we call it. That is the reasoning. And so artificial intelligence is it's nothing special in that sense. It is a couple of components, you bring it together, and you do the reasoning. If you combine that with statistics, if you combine, let's say, the knowledge of the world with statistics, knowledge of the world is not only a taxonomy, but you also have trends that you can collect, and then you apply your expert rules to the trends. You can make very, very powerful interpretation engines, and you can make them predictive. And this is really what our customers, I think, are looking for tools that help them to take decisions and to get alerted before the problem is there. So this AI is very good in predicting things. So if you have the data, you can predict. If you have a trend, you could predict with ingression or whatever the next steps of that trend. And this is what it is about. An example, for instance, would be the trending topics in Twitter, or the trending topics in Google. So what happens is there's a lot of data, and you can measure the frequency of the data. Because of the frequency of the data, you have a trend. Then you can make that trend a little bit longer, artificial, longer. So you can predict what the trending topics will be of tomorrow or next week. And that seems to be intelligent, but it is simply computing. And we call it AI.
So, Huub, you would say that the focus is not really on automating work or replacing people. It's about helping people make better decisions. I think you used that decision making. Yeah.
Yeah, in the banking world, of course, it replaced many people. In our market, I wouldn't say that it can replace people. I don't think that we, perhaps in the far future. Do you know the book of Harari, Homo Deus? Do you know that?
Wow. Yes.
Oh, if you go in that book, right? So his first book was Homo Sapiens, and this one is Homo Deus. And in this Homo Deus book, it's a fantastic book. He writes about how the future human being, how we will change, because it will be because of biotechnology and artificial intelligence. Those two components will make a life completely different. So through biotechnology, they make people that get older and older and older, and he thinks it can go to 300 years, 400 years in the end. And that is not science fiction. It's already working on it. And the thinking is also different because your brains will be connected to outside systems. So your brains are not only, will be extended. You have extended brains. So, and that is where the word Homo Deus comes from. So you know more than you know. And so when you connect your brains and the reasoning mechanism of your brains to systems that are outside of yourself, but are also reasoning, can you imagine what will happen? And this use of the same mechanisms that I was talking about, that promise of AI from, let's say, 50, 60 years ago, the 70s, I think it was, that it came up, that promise is already there, I think. So if you take the Tesla car, it can partly drive autonomously. And this is really where our customers go, Paul. So many of our customers want to develop or have to develop to compete smart products, smart kitchens, smart fridges, smart coffee machine, smart cars, whatever it is. So and the software, it plays an important role in there, right? So without software development, that wouldn't happen. And AI is software based. A metal cannot think. A metal cannot think. A chemical material cannot think. unless you put software in it, in the form of a chip or whatever. So AI, it was already always fascinating for me because the decision-making of people, but also the knowledge of the people can be extended. But what you do with it can be, let's say, very much supported by best practice, rules, standards. You don't have to make, so when you think everything for the first time, you will make mistakes, right? Mistakes. Then you know how to do it. But with this kind of technology, you immediately know what to do. So if you give this technology to a junior product manager, he can take wise decisions. You don't have to be 40 years product manager to take wise decisions. No, such a system can help you to take wise decisions. So it will replace people in a certain stage. And the whole idea of Industry 5.0, are you familiar with that, Paul? Industry
Yes.
5.0? Yeah. So 4.0 is to make digital twins for machines, but 5.0 is to replace people like judges. And that is a movement that is already long going on.
Yes, it is.
Attorneys, accountants, all that work, that is in a way has routines in it. And the decision making is not is objective, not let's say very personal, but objective. That will be replaced by rule-based expert systems, and they will be smarter and smarter because they are connected, for instance, to the Google database or something, where the knowledge sits. So the cloud also allows you to have an expert system close to yourself, but because it is connected to the sources out there, suddenly it is very powerful. And I cannot wait. In fact, I think I'm too old for this market. I wanted to be now 40 years, 50 years younger so that I could really move on. Because it's fascinating to see how we can use that and apply it to the wealth of our customers and mankind in the end. That is what I want. Now, let me now switch to machine learning.
Yeah.
So the AI side is a little bit rule-based in the end, but so it's become machine learning. There are many data. If you have many data, really many, think about scans of your brains, for instance. If you look at these images, that's a lot of data. If you look at the video of a football game, that's a lot of image data. And this is a lot. If you take that as an example, the same can happen as with the traffic data of a traffic, or data of a bank. A lot of data. Then it is for a human being not so easy to see the patterns in there, to see the correlations, and all the correlations that you have. And machine learning is not machines, but software that is based in general on what is called neural networking, and see it as a big matrix. And if you take all these data in a very big matrix, then the software can see repetitive mechanisms in there. And if you see repetitive mechanisms, you can ask somebody, hey, this correlation, would that be useful or not? Is that strange or not? Still some human input in it, right? So it's called annotation. So you still need to annotate. So for instance, if you want to teach a computer to recognize tumors in such a scan of your brain, then the computer is used, they look at many images. The system, like TensorFlow, for instance, is an example of such a neural networking system. They look at the patterns in the pixels, and they see these the gray areas in there, so which is more gray and light gray. They see the commonalities, and then they come back with certain things, and they need the coordinates. Where are they then? So it's just calculations. It's not nothing mythical here. It's calculations, and then we annotate and say, yeah, there's a good one. Yeah, there's a good one. Yes, a good. And the system remembers the good ones and takes out the bad ones. And by doing that again and again and again, you teach the system basically to recognize a tumor more precise than somebody else can do it with his eyes in a microscope. So you feed the data to that system, and it will come back with the correlations. And the correlations then, they need to be translated in algorithms. You can have also systems today that change their own algorithms on the basis of machine learning. I will talk about the example of Google, but that is quite dangerous. So Tesla would never do that. So Tesla, they have a lot of data available from the drivers, from the traffic, and so on. On the basis of that, they learn certain mechanisms by machine learning or deep learning, see the correlations, and these correlations then, they cannot be put in your car. Suppose you would have a Tesla, and the machine learning would say, okay, I changed the algorithm of Paul's car. No, that cannot happen. So what happens is, because of product safety, because of legal issues and so on, the algorithms that drive your car, if it is autonomous driving, these algorithms are tested, are approved, are certified, and so on. The machine learning is never certified. The algorithms are certified. So in the end, you have in your car, the autonomous driving is an expert system. So machine learning is like a discovery tool that in the end delivers you knowledge that you put in algorithms that create autonomous cars, fridges, kitchens, coffee machines, rockets, planes. They fly autonomously because they have built-in expert-based rules to react on sensor data or environment data or something else. So many people, I think, in my environment, don't understand the difference between what I would call AI and machine learning. So the AI thing is a broader term in general. You can have a lot of stuff in there, but the machine learning is, see it as a discovery tool, very mathematically, very statistically, you need big systems for it. And then see it in combination with the expert system. And these are in the end rule-based. I mean, rule-based, algorithm-based. I said Google, I think it was last week that I saw that 2 people from Google, from the ethical committee from Google, they were sent away by Google. They did not agree.
Right. Yeah.
Yeah. Did you read that? They did not agree.
Yes, it did. That's correct. And that's been brewing for a while inside of Google. Yep. Go ahead.
They did not agree with the self-learning mechanisms in Google, because in the self-learning mechanism, there was discrimination. And so, Google tries, of course, to identify the personalities of its readership, right? To send the right advertising. They go very deep in that. They go very deep also in the privacy of people. Google knows more about Paul Heller than Paul Heller knows about himself. Yeah,
Sure it does.
It's somewhere in those systems. And they have algorithms, of course, to send you messages that they think connect you closer to Google. That's what the market, that's the business model. And those algorithms, 20 years ago, they were quite direct. 10 years ago, they were really quite smart. But now they have so-called self-learning algorithms. That means the machine learning that they use are allowed, let's say, to update the paradigms of these algorithms. So if you say, for instance, that in the algorithm it says people under a certain age, or I don't send these messages under age. So so it would be 16 years or so. The self-learning mechanism, because of commercial things that in the background, could say, oh, okay, 12 years.
Yeah, right.
It would change the parameters. And that is what self-learning is. Also nothing magical there, right? So it's not magical, it's not like, but it's called, so if you, let's say, change the values that are applied by the algorithms automatically based on machine learning, for a search engine, I can imagine that you do that in that business model, but I cannot imagine for the foreseeable future, perhaps far away, if you read Harari, that would be implemented in Tesla, because all our customers fall, right? So in the discrete manufacturing and so on, medical devices and so on, all these people, they have such a responsibility to their consumers. And that is, if they make a mistake, against consumers with product safety, if something happens to a child and it is in the papers and so on, the share price goes down. So CEOs are very, very concerned about product safety and the liability, therefore the traceability and so on. And that is that a company is vulnerable if it sells products to consumers, if they die from it. You cannot die, I think, from Google, right? But you can die in a Tesla. And you can die from have the wrong electricity or something in the kitchen, or a child will be burned in the kitchen and the product safety was wrong. And the software should have seen that child and stopped everything and cooled everything down. So software is also a tool to make things safer, right? Not only more dangerous, but also safer. So if you take I drive myself a BMW, and it has also driving assistance. That is also an expert system built in the car, in the software of the car. And sometimes it breaks, it sees something with a sensor and then it stops my car. I switched it off. I can tell you, I don't want that. So that is if you are on a motorway for a long time at night, and it will help you if you fall asleep. It will not allow the car to go suddenly off the road. It will help you to steer and perhaps make a sound. Those are very, very helpful applications, basically, of AI. It can do things autonomously. So I don't like the word AI, actually, because AI is just a programming technology and all that. I don't like the word AI, also not machine learning, because it gives too much of a romantic idea about it. It's not that.
Yeah.
So I like the word smart. I like the word autonomous. Autonomous is a good thing. And in our solutions that also I have built with the customers, the products, they are more or less autonomous, more or less smart. Like it can also be more or less green, and safe. So you have to, if you characterize a new product, then the autonomous part of that is more and more important because of the digitization, of course. Is that a little bit, is that useful what I talk about?
Yeah, it was. I thought I liked the way you wrapped in psychological, physiological, ethical aspects in what you were talking about. And I think it'll be interesting to watch in the future as corporations have a corporate responsibility, and then the scientific community, I think, will struggle, much like we saw with gene editing and cloning, and just over the years, scientific community is going to push maybe the boundaries a little bit further than perhaps a corporation might, who has a responsibility to shareholders or to legal types of things. So it'll be interesting to see where it goes. But that was a very good perspective, Huub. Thanks for sharing that.
Yeah, so genetics was such an area, where you have so differences between Europe and America ethically.
Absolutely, and China.
Yeah, absolutely. Oh, yeah.
Right.
China, sure. So for instance, if you take the so-called security technology with cameras and all that, right? Face recognition and all that stuff, that is based on the same technology.
Yeah.
So you teach a machine to see something. In fact, the camera has an image, and you have software there that recognizes the pattern of that image. It recognizes the pixels, basically, the pixel structure. And did you ever see a pixel thing? It's just gray and black and gray nuances in there. And these machines, they recognize your face with it.
Yep.
They
Absolutely.
recognize face. So you can teach software. You can teach not a machine. You cannot teach a machine physically. You can teach the software with a machine to do certain things. So smart machines can only exist if they have smart software in it. Machines cannot be smart. Metal cannot be smart. Electricity cannot be smart. You can have now smart materials. But what is that? A material, then they have, let's say, layers of film, and they push, IBM did that already quite a while ago. They push chips that's so small that you cannot see them between the two layers of a film, plastic, two layers of plastic, and you have very small chips in between. You make the plastic a little bit electricity, and you have smart material. And the material can think, if you think that it can think. But I have debate with some of my people that I know about thinking computers. So a chess computer, can a chess computer think? That for me is a nice question. So you will have opponents and so on, but I am not so romantic about anything that has to do with computing.
Yeah. Well, Huub, if you kind of to extend what I hear you talking about, you say the metal doesn't do it, the software does it. And in many businesses, what were previously products are now done in software. So all the networking, all of the physical, the routers and the switches and all of that is now being done in software. It's called software-defined networking. It's just an example of we can do it all without any hardware. In fact,
but a software that will cool your you need a fridge to keep your stuff.
Yeah. But the point is,
you need something on wheels or with propellers to fly or to travel.
Sure.
So the software is in the end a text, right? Is a text, not more than a text.
Yeah, but I would say the line between the pilot's controls and the actual plane is there's a lot of software in there now. That, it's not just a wire anymore.
But
So,
closer to our business, innovation management, where would, let's say, AI and machine learning also could be applied. It's already since quite a while. I think that the expert system part, right, that I was talking about, can be very, very helpful in the decision making in product line management and in the scientific side of it and so on. It can be very, very helpful also with the business prediction. So if you, for instance, have a product and you see in the market that certain prices develop in a certain direction of materials that are relevant to your product, and at the same time you see the revenue plateauing, then you could predict that 6 months from now you have a problem, and then the product will go to the end of its life. There was a guy from Philips who once asked me, "Can you make me software," Huub, he said, that gives me a warning that I should start a new product or a revision of this product before it reaches the top of its revenue." And you can do that.
yeah.
So you can create software that gives an alert, a notification to the product manager, product line manager, business owner, whatever you would call it, brand managers. Yeah, okay, this product, its revenue is still growing, but I expect, and basically their own best practice expects, that this problem in 8 months from now will go down the drain. That is doable. It's absolutely doable.
Thanks for listening to my discussion thus far with Huub Rutten. I got so caught up in conversation with Huub that I lost track of time. So join us next week when our discussion continues as we talk about agile frameworks.
Thanks for joining us this week for Innovation Talks with Paul Heller. For additional information on today's topic, check out Sopheon.com, Sopheon.com, where you will find plenty of innovation-centric content and corporate best practices. If you'd like to discuss anything with Paul or would like to get in touch with the show, email us at talks@sopheon.com.